Hello, this is Mr. Collier, and today we're doing indefinite integrals. Okay, so let's take a look at some derivatives first. Okay, so this is the derivative. So if you find the derivative, you go this way, and integrating is going backwards to get the original function, basically. This is integrating. Alright, so let's look at the derivatives of these functions. So the first derivative here is 2x, derivative of x squared is 2x. So that means that if you do the integral, and here's the notation. Let's write down some integrals here. So this means the integral of 2x, and this has had the notation. So 2x is what we're finding the integral of. We have to stick in this symbol at the front and dx at the end to indicate we're doing the integral. So basic integral is we also call it the antiderivative. So what do you differentiate to get 2x? And that means x squared, right? The derivative of x squared is 2x, so the integral of 2x is x squared. Now if we look at the next one, x squared plus 3, the derivative is 2x. That means the integral of 2x dx equals x squared plus 3, because the derivative of x squared plus 3 equals 2x, right? And for the last one, it's also, or the third one, is also 2x. So the integral of, this seems to indicate that the integral of 2x is x squared minus 1, right? So you can see, like, the integral in each case is, the integral of 2x dx is x squared plus some number. The number keeps changing, but the integral of 2x gives you all these things here. So that's why we have x squared plus c to indicate that there is some constant c that we don't know, right? If you differentiate a constant, you always get 0. So any function of the form x squared plus a constant, the derivative will be 2x. So we need the plus c, right? And sometimes the plus c matters. So if you look at x squared, here's the graph of x squared. I kind of messed it up a bit, should go through there. And the graph of like x squared plus 3 is here. But if you look at certain points, like over here at x equals 1, the slope here is the same as the slope here, okay? So anyway, if you integrate either of these two blue parabolas, or if you differentiate either of them, you get 2x every time, right? So the slopes are the same here. So anyway, the integral of 2x could be any of these parabolas because they have the same slopes at the same x values, right? Let's look at these down here. So the derivative here is 3x squared. This one's 3x squared and 3x squared, right? So the integral of x cubed is not x cubed. The integral of 3x squared is x cubed plus a constant, because it could be -5, it could be 1, it could be anything. Okay, here's a screenshot of your formula booklet. If you want to find the integral of x to the power of something, you can do this, right? Because recall, if you want to find the derivative of x to the power of n, the derivative becomes n x to the power of n plus 1. If you want to go backwards, you gotta, sorry, I messed that up a bit. It's n minus 1 when you find the derivative. So if you want to go backwards, you get a plus 1, all right? And then you have to divide by this number. Let's look at some examples here. Let's just go straight to some examples on the next page here. So this formula says you increase the exponent by 1, basically. So you're going to have an x to the power of, that's 1, so it's going to become a 2. Okay, the constant stays, so the 2 stays, but then you have to divide by the new exponent, right? These are the same, so you have to divide by 2. There's always a plus c, and so it's x squared plus c. You can easily check, because if you find the derivative of x squared plus c, you get 2x, so it is correct. Alright? So basically, you just got to remember that constants, if you got a constant multiplied by x squared, then that stays. The exponent increases by 1, and that new exponent, we have to divide the function by that. So that's 2x cubed plus c. You can check by differentiating. This would give you 6x squared, so it's correct. Yeah. So always just keep the constant, increase the exponent by 1, divide by that new exponent. You can simplify, but no need to, I guess. Here we have 2 powers of x, so for both of them you can increase the exponent by 1, divide by that exponent. Increase the exponent by 1, divide by that exponent. And here, this is a constant. It's kind of like x to the power of 0, so it becomes x to the power of 1. Right? The derivative of 4x is just 4. Derivative of any constant times x is just a constant. So if you integrate, you get the constant times x. And for this one here, we have 2x, increase the exponent by 1, and divide by that exponent. You get 4x plus x squared plus c. Okay, here, well, that's divided by 4. Often it's just easy to write it as times a quarter, so it's a constant. You increase the exponent by 1, and then you divide by that new exponent. So this is actually x squared over 8 plus c. Okay, constants become 3x. We'll keep the 2/5 constant, and x, and you increase the exponent by 1 and divide by that exponent. So this is actually 3x plus 2 over 15x cubed plus c. Same here. Constants become times x. Increase this exponent by 1 and divide by that exponent. And the last one, same thing. Increase the exponent by 1, divide by the exponent. So it is 3 over 24 x to the power 6 plus c. Alright, now here, yeah, you actually, this will give you like an error if you try it with numbers on your calculator. Because just following our rule, we get x, we increase the exponent by 1, and then we divide by the exponent. So the problem is you cannot divide by 0, so that does not work. Okay, that's why it works for every power of x except for -1. That's the only one it doesn't work for. Okay. Here, this one you can do because it's not -1. You can just increase. Now, be careful with negatives. That's negative. You got to increase it. It becomes -4. Right, plus c. And over here, let's rewrite it first as x to the power of -3. And then we increase the exponent by 1 and divide by that new exponent. Here, yeah, we did something like this before. You can write it as half x squared minus 3x. And then we can integrate, increase the exponent by 1 and divide by the new exponent. Increase the exponent by 1 and divide by the new exponent. So we have x cubed over 6 plus 3 over 2x squared plus c. And similarly, rewrite it as an exponent with no fraction. So that is 4 times increase the exponent by 1 becomes -1. So you can write this as -4 x to the power -1 plus c, or -4 over x plus c. Yeah, you can't integrate each term here if it's in brackets. You can only integrate each term if it's like added together like this. Okay, so we need to expand. So this is going to be the integral of x squared minus x. There's also a plus 2x, and then a minus 2. I can simplify first, and then find the integral once everything is simplified. So increase the exponent by 1, divide by that exponent, increase the exponent by 1, divide by it, constants become just 2x, and then you get a plus c